Chemistry is awesome!
Right, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So welcome back to my channel. Right, class, today we are going to have a look at we are still in topic 1.3 stoichiometry, but this time around we are going to have a look at how to perform stoichiometric calculations using mole concept. Okay, so in the previous lesson or in the previous video, we have already have a look at how to write and also how to balance chemical equations using two different methods. Okay, so what were those two methods? If you can still remember, the first method was through inspection method. Okay, the one with that we are balancing the chemical equation using using inspection method. And the second method, we are using the ion electron method, and that method is especially for balancing redox equation, whether it was in acidic or in basic medium. Okay, maybe some of you might wondering why must we write a balanced chemical equation. Okay, the reason why the equation must be balanced because of this. Right, class, let's say we have a balanced chemical equation. So let's say if we know the moles of one substance in the balance equation, of course, okay, the balance equation tells us moles of all of the other substances in the same reaction. So that's why balanced chemical equation is very important, because if you balance it wrong, okay, we are going to have problems, especially when it comes to problem solving that requires us to calculate the moles or anything that is related to the equation, to the balance equation. Okay, for example, I'm going to use this reaction or this equation. So what do we have here? We have propane. Okay, propane is combusted in oxygen gas, and what do we get? Actually, are carbon dioxide gas and water. Okay, so from this equation, we know that 1 mole of propane reacts with 5 mole of oxygen gas to produce 3 moles of carbon dioxide gas and 4 moles of water. Right. So how can we read this equation? Okay, so it's like this. So we can say that 1 mole of propane reacts with or needs 5 mole of oxygen. Since oxygen is the reactant here, okay, and this oxygen reacts with propane, so in the form of a stoichiometrical relationship, we can write like this, or it is also can be written as 1 mole of propane produces 3 moles of carbon dioxide, or 1 mole of propane produces 4 moles of water. See the relationship here, okay, between the products and the reactants. Or if we don't want to use propane, we can also use the oxygen gas here. So same as propane. So since oxygen also is the product, is the reactant, okay, so therefore 5 mole of oxygen produce 3 moles of carbon dioxide, or 5 mole of oxygen produce 4 moles of water. See the relationship still, okay, between reactant and products. Okay, or if we look at the products itself, okay, say for example 3 moles of carbon dioxide gas are formed from 1 mole of propane, or 3 moles of carbon dioxide gas are formed from 5 moles of oxygen. And lastly, we can also use water, okay, to show the stoichiometrical relationship. For example, 4 moles of water are formed from 1 mole of propane, or 4 moles of water are formed from 5 moles of oxygen. See, so these are what we call as stoichiometrical relationship between the reactants and reactants, reactants and products, and products and products. Okay, so next, I'm going to show to you a few examples of problems. Right, so now let's start with the first example, example 1. Okay, so what do we have here? We have methanol. Okay, methanol, which is an alcohol, burns in air according to the given equation. So we have 2 moles of ethanol reacts with 3 moles of oxygen to produce 2 moles of carbon dioxide and 4 moles of water. Let's say the methanol used in this reaction is 209 grams, okay, or 209 grams of this methanol is combusted, completely combusted. What mass of the water produced in this reaction? Alright, so now let's look at the solution, or the answer to this example. Okay, so firstly, what we need to do is we need to determine how many moles of methanol combusted in this reaction. If we look back at the previous lesson, okay, 1.2 mole concept, you have already learned on moles, okay, and then the molarity. Okay, so we are going to use that in this solution. Okay, so since we want to determine the mole of methanol, so mole of methanol equals to mass of methanol divided by molar mass of methanol. Okay, so the mass of methanol is already given in the question, which is 209 grams divided by 32 grams per mole, and we are going to get 6.5313 mole of methanol. Okay, so this is the mole of methanol combusted in the reaction, right? So from the equation, or from the balance equation, okay, given that if we have 2 moles of methanol, okay, combusted, we are going to get 2 moles of carbon dioxide and 4 moles of water, and this reaction requires 3 moles of oxygen gas. Okay, so since we want to determine the mass of water, so we are going to look at the relationship, the stoichiometrical relationship between methanol and water. So from the equation, 2 moles of methanol produce 4 moles of water, but we only have 6.531 mole of methanol. Okay, more than 2 moles. Okay, so if 2 moles produce 4 moles of water, so of course if we have 6.531 mole of methanol combusted, of course this reaction will produce more than 4 moles of water. And how many moles of water actually produced in the reaction? If you calculate this you're going to get 13.063 moles of water. Okay, so why 13.063? Because 6.531 mole of methanol, okay, combusted. Right, but the question asks you to determine its mass, the mass of water produced. So since we have already determined the mole of water produced in the reaction, okay, so from mass of water, we know that mass of water, okay, equals to moles of water multiplied by or times molar mass of water. So mole of water 13.063 mole times 18 grams per mole, okay, which is the molar mass of water, and you are going to get 235.1 grams of water. So this is the answer for this question. Okay, example 2. A popular candy bar, okay, and don't ask me, okay, what candy bar is this, okay, it remains unknown. Right, so contains 21.1 grams of sucrose. So if you want to know what is sucrose, normally in the form sucrose can be found, okay, mostly can be found in cane sugar, okay, cane sugar, with the molecular formula C12H22O11. Right, so when this candy bar is eaten, so what happened was the sucrose in the sugar, in the cane sugar, is metabolized according to the given equation here. And do keep in mind, this given equation is unbalanced. It's unbalanced, okay? And the question is, find the mass of oxygen consumed and the masses of carbon dioxide and water produced by this reaction. Right, so what should we do first? Okay, so we are going to calculate how many moles of sucrose reacted in the reaction. So same as the previous example just now, so to determine the mole, we are going to use mass of sucrose divided by molar mass of sucrose. Okay, so given in the question, the mass of sucrose is 21.1 grams divided by 342.30 grams per mole. Okay, so if you are wondering from where actually we get this value, actually this value you need to calculate this value by yourself. If you forgot the values, no worries, you can just refer to the table of relative atomic mass in your tutorial book. At the back side of your tutorial book, you will find it there. Okay, so how to calculate this molar mass of sucrose. Okay, and then we are going to get 0.06164 moles of sucrose. So this is the number of moles of sucrose reacted. All right. Right, then we are going to look back at the given equation, but in the question, the given equation actually is not balanced yet. And then what we need to do, actually we need to balance the equation, and if you balance the equation correctly, so this is how it looks like. So this is the balance equation, okay. So from the balance equation, if we read the equation, see, 1 mole of sucrose needs 12 moles of oxygen gas. So this is the stoichiometrical relationship between the two reactants in this reaction. Okay, but we don't have 1 mole of sucrose. What we have is 0.06164 moles of sucrose. So therefore, it needs how many moles of oxygen? It needs 0.7397 moles of oxygen gas. So this is the amount of oxygen gas required if we have 0.06164 moles of sucrose. Okay. Since we want to find its mass or the mass of oxygen, okay, so we are going to use this formula. So mole of oxygen, okay, multiply by molar mass of oxygen, okay, and you substitute the values, okay, right? So mole of oxygen 0.7397 mole, and times 32 grams per mole. This is actually the molar mass of oxygen, because oxygen atom, the molar mass is 16. So oxygen molecule is O2, so 16 times 2, so we are going to get 32 grams per mole. You solve for this, you're going to get this answer, 23.7 grams of oxygen. So this is the mass, or this is the amount of oxygen required or needed in the reaction. Alright, let's move on to the next part of this question. Okay, so from the balance equation also, we knew that 1 mole of sucrose produces 12 moles of carbon dioxide. So this is also the stoichiometrical relationship between reactant and product. For example, the reactant is sucrose and the product is carbon dioxide. Okay, since we only have 0.06164 moles of sucrose, so therefore it will produce just 0.7397 moles of carbon dioxide. Okay, and we are going to do the same thing as what we did with oxygen gas, since we want to determine the masses, the mass of carbon dioxide. So therefore moles of carbon dioxide times molar mass of carbon dioxide. So we are going to get 0.7397 moles of carbon dioxide times with 44.01 grams per mole, which is the molar mass of carbon dioxide, and we are going to get 32.6 grams of carbon dioxide. So this is the mass of carbon dioxide produced in the reaction. Okay, so we are done with this question. So now let's move on to the next. Okay, also from the balance equation, okay, from the same balance equation, right now we are going to determine the mass of water. Okay, the mass of water produced in this reaction, the same reaction. Okay, 1 mole of sucrose from the equation, from balance equation. So 1 mole of sucrose produces 11 moles of water. Since we only have 0.06164 moles of sucrose, so therefore we are going to get how many moles of water? So you calculate this, we are going to get only 0.6780 moles of water. Okay, so once again, for the third time, okay, we are going to determine the mass of water. Just now we have determined the mass of oxygen and then the mass of carbon dioxide, and right now we are going to determine the mass of water produced in this reaction. So still we are going to use the same formula, mole times molar mass. Okay, so in this case, so mole of water 0.6780 times with molar mass of water 18.02 grams per mole, and we are going to get 12.2 grams of water. So this is the mass of water produced in this reaction. Okay, right, now let's move on to the third example, and to the next question. Okay, so in this question, question number 3 or example 3, the question is how many grams of phosphorus react with 35.5 liters of oxygen gas at STP to form tetraphosphorus decaoxide P4O10, and the equation is given here. Okay, right. So first of all, we need to determine the mole of oxygen gas. Okay, so in the question, it is stated in the question, this reaction occurred at STP. So you guys, did you guys know what is STP? What is STP? So STP actually is standard temperature and pressure. So what is the conditions for this STP? So the temperature is 0 degrees Celsius and the pressure is 1 atm. So these two conditions, this is what we call as STP. Okay, standard temperature and pressure. So at STP, if we have 1 mole of gas, any gas, 1 mole of any gas, so this gas will occupy the volume of 22.4 liters. Okay, remember at STP, 1 mole of any gas occupies 22.4 liters of volume. Right. So now let's get back to this question. So right now we know that since this reaction occurred at STP, okay, so 1 mole of oxygen gas occupies 22.4 liters. But in this question, we have at STP 35.5 liters of oxygen gas. So therefore, how many moles of oxygen gas actually, okay, did we have in this reaction? So to calculate this, so 35.5 liters times 1 mole of oxygen gas, 22.4 liters. Okay, divide by 22.4 liters. So we are going to get 1.5848 moles of oxygen. So this is the mole of oxygen gas. Right. Okay. So from the equation, from the equation, so if you look at this equation, 5 mole of oxygen produce 1 mole of phosphorus decaoxide, okay, P4O10. Or we can write it down as 5 mole of oxygen need 1 mole of phosphorus. Okay, so 5 mole of oxygen need 1 mole of phosphorus. But in this reaction at STP, from what we have calculated just now, okay, we only have 1.5848 moles of oxygen. So therefore, okay, 1.5848 moles of oxygen need how many moles of phosphorus? So we are going to get 0.317 mole of phosphorus. Okay, so this is the mole of phosphorus reacted with oxygen gas in this reaction at STP. Okay, and since we want to determine the mass of phosphorus, okay, once again, okay, mole times molar mass. So mole of phosphorus times with molar mass of phosphorus, okay, 0.317 mole times 123.88 grams per mole, which is the molar mass of phosphorus. So we are going to get 39.3 grams of phosphorus. Okay, right. Example 4. In this fourth example, this question wants you to find the volume in liters and also in milliliters of a 0.505 molar of sodium hydroxide solution required to react with 40 milliliters of 0.505 mole of sulfuric acid solution according to the given equation. Okay, so this is the given equation. We have 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to produce 1 mole of sodium sulfate and 2 moles of water. Okay, so firstly what we need to do is we need to determine, or we need to find, how many moles of sulfuric acid react in this reaction. Okay, since we were given the molarity of sulfuric acid and also we were given the volume of sulfuric acid solution used in the reaction, so from here we can determine the moles of sulfuric acid, molarity times volume, mv. Okay, mv. So this is the molarity or the concentration of sulfuric acid solution, and this is the volume, so molarity times volume. So we are going to get 0.0202 moles of sulfuric acid. So this is the quantity, or this is the amount of mole of sulfuric acid used in this reaction. And then we are going to look back at the equation given. So from the equation, okay, 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So therefore, if we have 0.0202 moles of sulfuric acid, so this quantity of sulfuric acid, okay, should react with how many moles of sodium hydroxide? We are going to get 0.0404 moles of sodium hydroxide, because the ratio is 1 to 2. 1 to 2. Okay, so this is the mole of sodium hydroxide reacted. Okay, if the mole of sulfuric acid is 0.0202 mole of sulfuric acid. Okay, next. So next is we want to determine the molarity of the solution. Okay, since molarity of the sodium hydroxide is already given, okay, and we have already determined the moles of sodium hydroxide from the previous stoichiometric relationship just now, and using this equation we are going to calculate the volume of sodium hydroxide solution needed to react with the sulfuric acid. Okay, so volume of sodium hydroxide, so we just rearrange this equation. Okay, so the equation, since we want to determine the volume, okay, so volume of sodium hydroxide solution in liters equals to moles of sodium hydroxide divided by its molarity. So the mole is 0. I think there is a mistake here. It should be 0.0404. Okay, so divide by, hold on, let's look back at the, I think it should be, yes, it should be 0.0404. Okay, so there is an error here, so typo. Okay, it should be 0.0404 moles. Okay, sorry for the mistake. Okay, 0.0404, so you just made the correction. Okay, divide by 0.505 mole per liter. So this is the this is the concentration of sodium hydroxide solution given in the question. So we calculate these two. Okay, so we are going to get 0.08 liters. Okay, so this is the volume of sodium hydroxide solution, and since the question wants us to determine the volume in liters and also in milliliters, so that's why if we convert from 0.08 liters to milliliters, we are going to get 80 milliliters of sodium hydroxide solution. Okay. Right, example 5. Okay, so this time in this reaction, we have a different reaction, and this time we have silver nitrate and excess silver nitrate reacts with 110.5 ml of an aluminum chloride solution to give 0.215 grams of silver chloride. And the question is, what is the concentration in mole per liter of the aluminum chloride solution? And this is the equation given. So now let's look at the solution, or let's look at the answer, how to solve this problem. Okay, so firstly we are going to start with the moles. Okay, we are going to calculate the mole of silver chloride. So mass of silver chloride divided by molar mass of silver chloride, and we are going to get 0.215 grams divided by 143.32 grams per mole. Okay, and this is the mole of silver chloride. 1.5 exponent -3, or 1.5 times 10 to the power of -3 mole of silver chloride. Okay, and then from the equation, so that's why balanced chemical equation is very important, because if you balance it wrong, so the stoichiometrical relationship would be wrong also. Okay, so that's why you need to balance them. If the equation is not balanced, we need to balance the equation first, okay, or balance the equation correctly, okay, or else we are going to have problems. Okay, right. So since the equation given here was already balanced, okay, alright, and then from this equation, let's look at the relationship between silver chloride and aluminum chloride. So from the equation, 3 moles of silver chloride, okay, silver chloride, which is the product, okay, produced from 1 mole of aluminum chloride. Okay, so therefore, if we have 1.5 exponent -3, or times 10 to the power -3 mole of silver chloride, so they are produced from how many moles of aluminum chloride? So you calculate this, you're going to have the answer should be 5 times 10 to the power of -4 mole of aluminum chloride. Okay, so this is the mole of aluminum chloride, okay, reacted in this reaction. If the mole of silver chloride produced is 1.5 times 10 to the power of -3 mole. Okay, next we want to determine the molarity, okay, of the of aluminum chloride. Okay, so molarity equals to moles of aluminum chloride divided by volume of aluminum chloride in liters, aluminum chloride solution in liters. Okay, so 5 times 10 to the power of -4 mole divided by the volume, 0.1105 liters, and we are going to get the concentration of the aluminum chloride solution is 0.00452 mole per liter, or molar of aluminum chloride solution. Okay, right. So that's all for this lesson. So in the next video, we are going to have a look at another or the next part of this chapter. I'm going to teach you on
purity of samples.
Purity of samples. For example, let's say we have an we have an impure sample. Okay, how actually we are going to determine how pure or what is the percentage of the pure sample in the impure sample. Okay, class, so that's all for now. Okay, alright, bye.